Hello, it's me, Emmeline Xiao, and we are at 3.3 partial fractions of learning unit number 3, that is polynomials. So in this video, I will talk about how to express rational function to partial fractions. So we have few types, but in this video I will cover the first two, and then we will talk about the steps on how to do this, on how to express rational function to partial fractions. And we will also talk about proper and improper function. What we have to do if we have improper rational function, and what we can do if we have a proper rational function. So yeah, it's not a long video, so don't worry about that. I think we can start now.
3.3 partial fractions. For the learning outcomes, so here we only have one learning outcome, that is students should be able to express rational functions in partial fractions. How to express an expression into partial fractions? Two simple algebraic fractions can be combined to become a single compound fraction. For this example, we have 2 over 3 plus x plus 3 over 4 minus x, and we get x plus 17 over x plus x times with 4 minus x. So here, we will do the reverse process. That is to express an algebraic fraction as the sum of two or more simple fractions. So what we will do is, we want to do, for example, x plus 17 over 3 plus x times with 4 minus x, and then we will get 2 over 3 plus x plus with 3 over 4 minus x. How to do the reverse process? We will have a procedure how to express an expression in partial fractions. So we will have 5 steps. Step number 1 is we have to determine a rational function of the form fx over gx is proper or improper rational function. If the rational function is improper, we have to do long division. If the rational function is proper, we can proceed to step number 2. We just have to factorize the denominator of the rational function if applicable. And then we have to express the rational fraction based on the type of the denominator's factors. So we will discuss about the type of the denominator's factors later. So we just proceed to step number 3, which is multiplying throughout by denominator's factors. And then we will have some constants, and we will have to find the values of these constants. Then that is step number 4. We will have 2 techniques. The first technique is we can substitute suitable values of x in order to find the arbitrary constants, or if that is not enough, we can go to the second technique, which is we just have to compare the coefficients of x terms and the constant terms and solve the resulting simultaneous equation. However, in some cases, we have to use both techniques in order to get all the values. So this depends on the situation. So some question, we can just use the first technique, we will done and go to the step number 5. But somehow, or in some cases, we have to proceed to use the second technique too in order to get the all values of the arbitrary constants. And then when we're done with step number 4, we have to go to step number 5, where we have to express the expression in partial fraction. So before we go to the type of denominator's factors, let's discuss about what is proper fraction and improper fraction. So proper fraction is when the degree of the numerator is less than the degree of the denominator. For improper fraction, this is when the degree of the numerator is equal to or greater than the degree of our denominator. So again, for step number 1, we have to check whether the fraction is proper or improper. So if it is improper, we have to do long division. If it is proper, we just go to the next step. Okay, so there are some rules on how to express fractional polynomial function as a sum of partial fractions. So the first rule is when the denominator is linear factor or denominator with linear factor. So corresponding to a linear factor ax plus b in the denominator, there is a partial fraction of the form a over ax plus b where a is a constant. So please bear in mind that we will deal with a proper fraction. Let's look at one example on how to express fractional polynomial functions as a sum of partial fractions with the first type, denominator with linear factor. Let's discuss this example 10. We have to express 2x minus 10 over x plus 1 x minus 2 in partial fractions. So for step number 1, we check this is proper fraction, so this is okay, no need to do long division. And then we go to step number 2, which is factorize the denominators, and we already have the factorization of denominators here. We have two factors, x plus 1 and x minus 2, two linear factors, so we'll have two fractions for our partial fractions. Okay, so we let 2x minus 10 over x plus 1 times with x minus 2 equals to a over x plus 1 and then plus b over x minus 2. Okay, so that is for step 2. Now for step 3, we multiply throughout the denominators factors. So we have a times with x minus 2 plus b times with x plus 1 over x plus 1 x minus 2. So now we can see that both sides we have single fraction and we have the same denominator, and because of this we know that we will have the same numerator. Hence we have 2x minus 10 is equals to a times with x minus 2 and then plus b times with x plus 1. So we're done with step number 3 and we get the identity. Now we can go to step number 4 in order to get the values of a and b. So we try to use the first technique where we substitute a value of x. So first we substitute x equals to 2 into our identity, and then when we substitute this x equals to 2, we get the value of b equals to negative 2. Okay, and then we try to substitute another value of x, which is negative 1, into our identity, and then when we substitute this value, we get a equals to 4. So now just by using the first technique, we can get both values. Okay, so we don't have to use the second technique, and then we go to the last step, and that is our final answer. Hence 2x minus 10 over x plus 1 times with x minus 2 is equals to 4 over x plus 1 minus 2 over x minus 2. So that is our answer. let's look at the final answer. We have double lines for the equal signs. Okay. So if we look back at the previous on how we express our fraction or compound fraction into partial fraction, and then we use 3 lines. So if you want to use 3 lines also can, 2 lines also can. The meaning is still equal signs, so I will still accept both answers. So don't worry about that. Just use what kind of equal sign that you want. You want to express a fraction where the denominator is a quadratic factor. So corresponding to a quadratic factor ax squared plus bx plus c, in the denominator there is a partial fraction of the form ax plus b over ax squared plus bx plus c, where a and b are constants. So here is when we have a quadratic factor, and this quadratic factor cannot be factorized into linear factors. So we will use this idea, or this, we will apply this information. Okay. So as our denominator is a quadratic factor, and we know that a quadratic means we have a polynomial of degree 2, right? And then in order to make this still proper fraction, okay, so for the numerator part, we will use a polynomial of a degree 1, which is a linear. That's why we have ax plus b as our numerator. So that is the idea. We still deal with a proper fraction. So if our denominator is of degree 2, hence our numerator must be at least less 1 degree, which is of degree 1 in this case. Let's look at example 11. We have 1 minus 19x over x minus 7, and then times with x squared plus 2x plus 3, and we want to express this in partial fractions. Okay, so we have to determine whether this is proper or improper rational function. Okay, so we can see that the degree for the numerator is less than the degree of the denominator. So this is proper function. Okay, so we can go to step number 2, which is factorize the denominator of the rational function. Okay, so check x squared plus 2x plus 3 whether we still can factorize this quadratic expression. But once we check we cannot do that, means we have a linear denominator factor and a quadratic denominators factor. Okay, so we will combine the situation of type 1 and type 2 here. Okay, so now let's express the rational fraction based on the type of the denominators factors. So we will have this. Okay, we use let 1 minus 19x over x minus 7 times with x squared plus 2x plus 3 equals to a over x minus 7. Because x minus 7 is linear, so we use a constant for our numerator. And then plus bx plus c over x squared plus 2x plus 3. So our denominator factor here is a quadratic, so we have to use a linear for our numerator. Okay, now we go to step number 3, multiplying throughout by denominators factor. So we get this a times with x squared plus 2x plus 3, and then plus, put that in the bracket bx plus c, and then times with x minus 7 also in a bracket over x minus 7 times with x squared plus 2x plus 3. And then as we have the same denominator, both
fractions, both sides is single fraction, so we know that we will have the same numerator. Okay, so here we have 1 minus 19x equals to a times with x squared plus 2x plus 3 plus bx plus c times with x minus 7. And then when we try to expand this, we get this. 1 minus 19x equals to ax squared plus 2ax plus 3a plus bx squared minus 7bx plus cx minus 7c. Oh, no need bracket here. Okay. So first, for the next step, step number 4, we try to do, or we want to get the constant's value, determine the constant by using the first technique. And then what we can do, if we look at this, we have this. So what we can do here is we can substitute the value of 7. So 7 minus 7 is 0. Anything multiplied with 0 will get you 0. So we will eliminate this part and we will get the value of a. Okay. So substitute x equals to 7 into the identity. And we have negative 132 equals to 66a. Hence our a is equals to negative 2. So now, if we look back here, we cannot substitute other numbers. So we will use the second technique, which is we compare the coefficients of x terms and the constant terms, and we try to solve the resulting simultaneous equation if we need to. If not, we just compare and we can get the values. Okay, so this is the second technique. We will use this part for our second technique. Okay, we just compare the coefficient or constants. Okay, so now let's compare the coefficient of x. So we have negative 19 equals to 2a minus 7b plus c. And rearrange, we have negative 15 equals to negative 7b plus c. Okay, so we don't know what to do next, so just let this as equation number 1 here. Okay, and another thing that we can compare is the constant. Okay, compare the constant. We have 1 minus 3a minus, no, 1 equals to 3a minus 7c, sorry. And previously, we have a equals to negative 2, right? Hence, we can get the value of c here, which is equals to negative 1. And once we have value of c, we can go back to our first equation. And then we can get the value for b. Okay, substitute c equals to negative 1 into that equation 1 and we get b equals to 2. So for step number 4, we need both techniques in order to determine the constants a, b, and c. But don't stop here. We still have step number 5, the last step. Express the expression in partial fractions. So our final answer is this. Hence, 1 minus 19x over x minus 7 times with x squared plus 2x plus 3 is equals to negative 2 over x minus 7 plus 2x minus 1 over x squared plus 2x plus 3. Okay, if we look back at how we expressed this earlier, we use positive a, b, and c. However, if the values that we get is a negative number, for example, a is negative 2, right? So we just put there, negative 2 there in our answer. Okay, so this is okay. And again, we can use double line or triple lines here to express your equal sign. Both are accepted. Don't worry about that. Okay, so this is the answer. were our examples, example 10 and 11. I hope you understand these two types on how to express rational function to partial fractions. And yeah, thank you for watching. May God bless you. Bye bye.